don't forget to cover your client side. And as Ralph said, this is me. I am Jonathan Creamer. Same thing as coffee creamer is how you spell it. You can't tell how many times I've been in grocery stores or wherever, and people like laugh at me when I ask them to spell my last name and say Creamer. So that's kind of fun. As he said, I'm a JavaScript engineer here at Ubuntu. I've been here for about 2 years, and I've really enjoyed it because I literally do nothing but JavaScript, which I love. JavaScript is something that has always been pretty much my favorite language to work in. I've done Cold Fusion and .NET, but there's just nothing like JavaScript to me. It just kind of has always made sense. It's kind of where I got my start back when I was about 13, doing HTML, CSS, and all that. I live here in Nashville, and this is the cool Nash.js logo for our user group. We love our user groups here in town. And yeah, so I want to go ahead and jump in. So there's this quote by a guy named Michael Feathers, and it's in a book he wrote called Working Effectively with Legacy Code. And the quote says that legacy code is code without tests. And I think that he said this because he really understands the importance of testing code in general. And throughout today's talk, my goal is to kind of introduce you guys to just briefly what testing is, unit testing, talk about why we do it, give a brief overview of some TDD things, and maybe a little bit on BDD, just kind of some other testing methodologies. And then we'll jump into client-side testing. And then if we have time at the end, I want to show off a little bit of a demo that I TDD'd, but I keep going long, so we'll see if I've got enough time to do a whole thing on that. So the first thing I want to start with is, as I was preparing for this talk, I took a step back myself even really to think about what the term unit test really means. And so I used our friend Google, and I just literally said define :unit and define :test as separate words on Google. And the results I got back, I really liked these definitions. So I'm just going to read them real quick because I think they're really good. So first of all, unit is an individual thing or person regarded as single and complete, but which also can form an individual component of a larger or more complex whole. And secondly, a test is a procedure that is intended to establish quality, performance, or reliability of something, especially before it's taken into widespread use. Right? So I really like those two definitions, and if you kind of combine those two things together, you really get this idea that a unit test is a method by which we determine if a given unit of code behaves as expected by asserting results given certain parameters and conditions. But I want to jump back here just for one more second because there's a couple things I really liked about these definitions that really kind of changed, not changed, but reinforced some of the ideas of unit testing in my head. And first of all is the fact that it says it's an individual thing, right? And then second of all, single and complete. I really like that phrase right there because what it really emphasizes in terms of what a unit of code is that it could be a small function that is itself a single function, small function, but it is a complete function, right? So you get this idea that it's something that can live outside of itself, right? And it forms an individual component of a larger, more complex whole, right? So you get this idea that units of code are these small, reusable pieces of code that you can pull away and they make sense, but they also are part of this larger whole. And then in terms of a test, this definition kind of presents three things. It presents quality, performance, and reliability. And those things are things we look at for in code. And then before it's taken into widespread use, that right there is a great piece because it talks about, unit testing is all about trying to get things working ideally before you make it out into production. So unit testing is about getting the smallest possible unit of code and isolating it and testing it. Okay. So why do we test? It's an excellent question. First of all, the main thing that you'll hear about testing, and I tend to agree with this, is that it's good for bugs. It's good for bug squashing, and there's a couple different reasons for that. The first of all is if you're doing unit testing on your code, before you get it out into production, you're able to spot more bugs ahead of time. Okay, because you end up having to prove that your code works. It kind of almost just makes sense, really, to me, that you would write a piece of code and then write a unit test to prove that that test or that code is actually working, right? And so to me, it just kind of makes sense. It gives you a little bit of proof and assurance that your code works. It's also kind of a nice thing for record keeping. If you have a bug, you can fix it. If you get, like, a user sends in a bug report, what I like to do is rather than just fix the bug and move on with life, I prefer to write a unit test that reproduces that user's experience and then fix it. And then that way you actually get a nice documentation sort of a bug. So if you ever have somebody else submit a bug that's sort of similar to that, you can go back in time in your unit test and see, oh yeah, I had a bug and I remember, and this is how it was fixed, right? So that's a nice kind of advantage. And to me, it's all about fixing bugs now versus later. If you're not doing any kind of unit testing, you end up running into this situation where you end up testing your code in production, which is not something that is an ideal scenario. We don't want to test our code in production because it's just not good. It's just not smart. And the thing with testing in general is that if you don't test your code, somebody else is going to inevitably test your code. That could be a coworker. It could be your boss in a demo. I mean, how many of us have had demo fails? But unit testing is this nice thing that lets you get testing done before you put it out into production. Because when you wait to test things in production, you end up seeing things like this, where you say, "Oh my goodness, I tested. I thought it looked like it was working, and it worked on my machine for a while. I promise." But then you do these things, and they're supposed to work like we say that they're supposed to work, right? So the idea is that we want to test our code now and reduce the bugs that we have in our code later. And our bosses really like that too. Even though a lot of bosses are kind of going to be a little hesitant at first, the idea of writing a little bit more code up front with your tests, it's important to let people know that you're really going to save yourself time with bugs later. Okay, so another reason that it's good to unit test is that it helps you with the design of your code. This is because when you're writing tests, you're basically writing the code that interacts with your API, with what you're working on, right? So as you're writing your code and you're unit testing it, you're able to think about things a little bit differently than if you just wrote out code just right there, because you have to think about edge cases. It'll show you any flaws you have in your design, right? Because like I said, you're writing tests. Tests are consuming your API of your code. So it really makes that a little easier. And another thing that I really love about unit testing myself is that when you get ready to add a new feature to your code, it's easier to do it without breaking things. And the reason is because once you have this nice big suite of unit tests, when you get ready to add some new feature in, you can go add the new feature and run the tests and make sure you haven't broken anything. And this is something for me that I know has happened personally. I was on a project and I had some Jasmine tests on some JavaScript code and I had done a feature and it was done and out of production, and then one of my coworkers came in and was asked to do something on top of what I had done, and he did it. He did the feature and put it out there, and everything looked like it was fine. But then a few days later, out of production, we found a bug. And come to find out, he didn't run my tests that I had written. And when I got a hold of the bug report, I immediately ran my unit test, and it saw exactly where a test that had been passing before he wrote that feature was now failing, right? So it actually pinpointed exactly where I needed to fix my code, which was a really cool. I was really jazzed when that happened because it was really even more proof to me that what I was doing was useful. So at that point, I wrote another test that proved that the bug was happening and then fixed it. So it's nice because then you get that nice documentation, and it makes it easier to ramp up new developers if you've got your unit tests too, because you end up creating this living, breathing documentation when you're doing unit tests. A lot of times, for me now, what I'll do is if I'm getting ready to use some sort of new Node library or some client-side library, a lot of them have documentation written out, and I'll check that out as well. But I really enjoy going and checking out the unit tests because it gives you an opportunity to not just see like how the API of the library or framework works, but then see how to call it and how everything works and all the different edge cases. And if that library was tested and thoroughly, you can see every use case that they thought that the library should be used for. So it's a really nice advantage to have. So another reason that we want to make sure that we're testing our code is for maintainability. There's this really awesome quote here by a great JavaScript developer named Cody Lindley, and it's in an article on TechPro. And he said, if code is tested, it's typically understandable and maintainable because it has been written to be tested. And this is something that, as I've been doing unit testing, I have found to be very true, that a lot of times a maintainable feature is testable, and vice versa. Testable features tend to be maintainable features. And that's really because testable and maintainable features have the same types of things. They're small functions that are easy to read, documented, decoupled, and reusable things. And that's just kind of by nature what maintainable features are, and that also happens to be what testable functions are, testable features are. You end up with testable code, it ends up being human readable, it ends up usually being small functions that aren't, you don't want to have 50-line functions. You end up breaking things down smaller just because it's really hard to test code that's that large. It's easier to code on a team, really, if you're doing a lot of testing, because since you're doing these smaller functions, you know, you're not running into Git conflicts. I mean, now that you've heard Jordan talk about Git conflicts, you can fix them easier, but you don't have to have as many conflicts because they're smaller functions, right? You're not going to collide with Joe down the hall working on this 100-line function because you've got these smaller pieces, right? And they're individual units that are, you know, their own thing, right? So just kind of in general, I think testable code translates into maintainable code. And maintainability obviously is something that is extremely important for the longevity of a project, and it's something as developers we strive for. You know, we want to write code that sustains itself for the test of time. We want it to be maintainable for our future coworkers because you don't want to aggravate this guy down the road, and even for yourself. I mean, we've all done this thing where we've written a line of or some bit of code, and then a week later come back and been like, oh my gosh, what was I doing, right? And so tests are a great way to ensure that what you're doing is maintainable and help bring your coworkers up to speed faster about the code that you've written. So there's a lot of different types of tests, and some of the terminology gets a little bit confusing. So I just want to clear a few things up. When I first started getting into this, my boss and I would go back and forth about like this and that and the other about, oh, this is a test and this is unit test and TDD and but you know, it kind of gets a little muddied. So first of all, unit tests are what I've been talking about so far, and unit tests have kind of become the basis for different flavors of tests. You have the ability with just a normal unit test, which is just, you know, a test that tests a unit, period. You can do that after you've written code. That's fine. A lot of people do that, and it's not uncommon. You've got test first development, which just means you write a test and then you write your code. But then beyond that, there's a couple different sort of methodologies of testing that have come out. And TDD is probably, at least to me, the most common one, and that is written or coined by a guy named Kent Beck. And TDD is all about test-driven development. It's all about writing out an assertion, writing out a test, watching that test fail, because you haven't written any code yet. So you watch it fail, and then you write the simplest code to make it pass, and then go back and refactor your code and eliminate any duplication and take a look at what you just did. And so we'll talk more about that in a minute, but that's known as red-green refactor. Then you've got BDD, which is kind of one step above TDD, and that stands for behavior-driven development. Behavior-driven development uses a common language to create like specifications for an application, and it's a little bit more integration-style testing in that an integration test being something that tests multiple systems at once. So BDD is another really great method for testing. You should check that out. I'm not going to talk much more about it other than that. And then integration testing, as I said, is testing. You know, if you want to write just normal unit tests, would be just like very small, isolated pieces of code. Integration testing will be something where you want to test some code with the database, for example, or with some other third-party logger or something, right? You don't necessarily want to not test your code with the database. You want to just have at least something that says, you know, it's working. And then the last thing is regression testing. Is kind of what I talked about a minute ago, where after you after you've written some code and you get ready to do your new feature, you regression test to make sure that you haven't broken anything when your new functionality is added. So no matter which framework methodology you go with, you need to do it and test all of your units. It's very important, and I highly recommend it. So I want to kind of jump into a little bit more about TDD, because TDD is what I tend to use when I'm doing my testing. It gets me in kind of a routine, and I find that after I've been testing for a while, I get on a project that isn't tested, and I just want to start writing tests just because I've gotten so used to it. You end up just writing a test, watching it fail, making it pass, writing a test, watching it fail, making it pass, and you get into this thing where it gets really fast and it's almost second nature. But you just have to get started doing it, or you won't do that. So with TDD, there's a couple things to keep in mind. First of all, when you write a test and then you watch it fail, and you go in to implement that test, the solution to make that test pass needs to always be simple. As a developer, we know it's very tempting to write code, and we're sitting here and we're thinking, okay, so I need to do this, but then also what about this, and maybe in like 2 weeks what about this, and all, right? Don't do that when doing TDD. First of all, it's just a waste of time, and second of all, it's just not the point of TDD. TDD wants you to get out the simplest solution to make the test pass, to be lean, and that's how you end up getting this maintainable code in these decoupled systems, is that you're thinking about the simplest solution because you're forcing yourself to do only what needs to be done at the moment it needs to be done. And you end up kind of in this almost code discovery process. Sometimes I'll say TDD is almost like code discovery, because as you're writing out your tests, you end up thinking about things like, write this test and it needs to do this, right? So you get into that kind of thing. You don't want to write future code. You want to write make it pass code. And as we said before, it really does help you improve your API, because as you're doing these quick TDD tests, you're thinking about how you want your code to be called. Another really great thing with TDD is that refactoring becomes much easier. When you get ready to do something like swap out a database or swap out some sort of logging system, whatever, any sort of even minor refactoring, you can go in and you have this big long suite of tests. So that means that your public API is tested. So you can go in and switch out some implementation details and rerun your tests, and if everything still passes, then you're good to go, right? So at that point, you've given yourself even one more extra guarantee that the code you've written and swapped out with your refactor is good to go. TDD really helps reduce coupling, and that's quite simply because it's hard to test coupled code that has a lot of dependencies. If you're working with classes or functions that have 9, 10 different dependencies in them, you're just gonna want to curse the world, because it's not easy to test code with a lot of dependencies. You have to think more about how your objects are interacting when you're doing TDD, so you get this really nice decoupled code. Okay, so now I want to jump into client-side testing. For some reason, a lot of times when we're asked if, as developers, we write front-end tests, we tend to want to be, yeah, it's like a little scary. It's because people will say it's hard and there's a lot of things to worry about, but it's really not bad. Client-side testing, there's reasons we have to do it now. Applications are much larger than they've ever been before. You've got single-page applications. You've got these big frameworks like Angular and Knockout. you know, the whole REST API stuff going on these days. There's not as much server rendering going on. Everything's rendering on the client. So it's very important, really, in my opinion. I argue it's at least as important to test client-side code as back-end code, since the only way really even to test client-side code is to run it, and it compiles at runtime, right? So you have to actually open your browser to make sure that your JavaScript works. You know, we've known that back-end unit testing is important for a long time. We don't always do it still, but it's, you know, we've known for sure that back-end testing had its place. But client-side testing is becoming way more important than it ever has been before. And some of the other benefits of it, it allows you to test offline. I was sitting in the Houston airport one time, and there was no free internet, which is so lame. And basically, I was needing to get something done, but since I had been doing some Jasmine stuff, and I didn't have any, I wasn't coupled to my internet connection, I could run my unit tests and work because I didn't need the internet, and I could test offline with Grunt and not even in the browser, right? I don't have to spin up my entire application to test this one new feature. I can build the feature out in my tests and make sure it's working, and then spin up my browser. I'm not saying you want to like never test in the browser. That would be really stupid. But you know, it's just a nice thing to be able to write all your tests out, do your work, and not have to be worried about the browser in running your application. So I mean, there's a lot more things that we hear about why we don't do client-side testing. It's harder, as people think. You have to worry about the DOM. It's just more tempting to reload, develop, you know, write some JavaScript, refresh the page, right? It's not very efficient though. It's more code, it's more work. I want to just kind of get rid of those ideas about client-side testing for you today. I want to get you started thinking about how client-side testing is important, and it's really not hard to do. There's just a couple things you need to think about. The first piece is that you need to abstract the DOM. Use some sort of tool. Angular is the hot right now. I do like Angular. I think it's a great framework. I'm not saying go use Angular, but it is really good. Things like Backbone, Knockout, Ember, you name it. Just use something that hides your DOM away from you, and your life's going to be a lot easier trying to do client-side testing. If somebody's just using vanilla JavaScript or jQuery and trying to do unit testing, I mean, I'm not saying it's impossible, but it is definitely more difficult because you have to test the DOM, and that's just slow and clunky. So having a framework like this really helps speed up that process. So the second step is picking a testing library. I've mentioned Jasmine a few times, but there's also Mocha and then QUnit. And QUnit is actually what we're going to talk a little bit more about today. But those are the three kind of, I think, biggest ones. There's probably lots more out there that I haven't mentioned, but you need to pick a testing library. I like to have a mocking library to basically kind of mock out some dependencies if I do need to do that. And we'll talk about Sinon. And then a great way, like I've said, is if you're trying to get started doing this testing stuff and you don't necessarily even have like a new project to do TDD on, just TDD a bug. The next time you get a bug report in, don't just go fix it. Write a test that proves your bug is happening so that you can watch it fail, then fix it, watch it pass, and then, you know, if you need to do anything else, you're good to go, right? So that's a great way really to get used to TDD and get some practice, and you'll find that it really makes you better at testing. And everybody has long bug reports, right? And we don't have bug-free code. It's not possible. So by fixing that bug, you again get your record of how to fix it. So QUnit is the testing library we're going to jump into here for the client side today. It's very simple. It was written by the jQuery guys, which, you know, we love the jQuery guys. They have done a lot of great things for us. It's very simple to set up. The assertions that you use inside your tests are very easy, and there's a very low barrier to entry. It's as easy as just like an HTML page like this. You've got the CSS and JavaScript for QUnit. You've got the two divs here. I guess you can see my mouse. QUnit, QUnit fixture, these things are things you can use to insert DOM elements if you need to, and they'll get cleaned up. Then you need your code and then some tests, okay? And so the first step to writing tests in QUnit is you don't have to have modules, but I recommend it because it allows you to break up your tests into these different modules. The way it works is you'll say module and then give the module a name, and every test that you run after this module falls into that module. So then the next time you need a new module, you just put in module again, right? And so then you can actually also use these setup and teardown options. Setup will run before every test. Teardown will run after every test. And again, if you use this module in the setup and teardown, you'll have your tests after it, and then you just do another module and it resets it. So the first assertion that you'll probably use a great majority of the time is the equal assertion, and it's not equals, just so you know, it's equal. What used to be equals and now that's deprecated, so it's just equal. These examples are granted arbitrary, but I just want to very simply illustrate how this stuff all works. So you've got this API here of equal, and then an actual value, what you've expected, and then an optional message. You don't have to have these messages, but it makes your display a little cleaner. So here you just pass the tests, give the test a name, a function, and then you just start testing things. So here I'm just going to test an add function. Really simple, but I expect that adding 2 plus 2 should equal 4, and these two numbers should be equal, I hope. So if I run this, okay, good, they are, that 2 plus 2 does equal 4. All right, so we're good there. I also want to point out here that this is, the equal here is loose equality, so the number 2 equals the string 2. So just keep that in mind. This is not equals equals equals, which would be strict equality. This is, and there is a strict equal as well, but this is just loose equality. Yeah, there's those two things there. So the equal operator will not compare objects, right? And that's kind of the same thing as if you were just doing equals equals in JavaScript. You can't just object equal equal foobar because objects are reference variables. So you can't say object foobar, that will fail. Doesn't work that way. So if you need to do testing on a object, you'll do deep equal. And deep equal will go through and do key value pair comparisons recursively on the object. And it has the very same API. Oh, I guess I might have those backwards, I think, actual expected. But same sort of thing there. So next is OK, and this one is very, very simple. It's useful for if you have some sort of Boolean function. Lots of different cases for OK, but it's literally just, OK. Is number 7? Yes, 7 is a number. Very, very easy there. Okay. There's a prop equal, or excuse me, this is the assertions for throws. If you are writing a function that you know is going to throw some sort of error, you can use this throws, and I know that inside of this, do it is going to throw an exception. And so I can prove that my code, if you're working with some sort of custom errors or some weird case, this function throws an error, you can use that one. And then you've got prop equal. This one allows you to test that an instance of a constructor has the property values that you expect on it. Right, so I've just got this very simple foo that accepts bar and sets the stub bar up on it. So when I create an instance of new foo and pass in 1, the this pretty much of my instance is going to be bar 1. And so that's prop equal. Every one of these assertions that I've mentioned has a not. You can do not equal, not okay, etc. But in general, I think with unit testing, I don't tend to do a lot of the negative testing, but they are available to you if that's something you want to do. JavaScript is inherently asynchronous, right? And so testing asynchronous code gets really hairy because you'll run some code and then the event loop goes to another cycle and your test doesn't run. So QUnit has this async test rather than just test. And what you can do here is, if I'm testing some sort of function here that does, like, this is obviously, again, an arbitrary example, but if this was an AJAX call that was going off and doing something, or if you're doing something in like an animate, just something asynchronous, this test is going to run, and then nothing's going to happen because it's going to skip it, right? If you had an equal down after here, it would just run and nothing would work. You'd hang and you'd be confused. So that's why this async test is useful. I'm using a promise here on my foo async, and I'm doing my equal comparison off of this resolve, and then I'm calling start. Okay, start is the key here. Start basically says, I know this test was async, and now that everything asynchronous is done, pick back up where you left off. Okay, so when you run this, you can see that the set timeout is still working. If I took that start out of there, the thing would hang and it wouldn't work. It wouldn't come back with any results. So that's really important to keep in mind, because asynchronous code, in my experience with unit testing, has been the most difficult thing to work with, and it's just the most difficult thing to work with in JavaScript really in general. So it's really, really simple with QUnit to just do that async test and start your code when you're ready. You could be like bad news Brian here, and your unit test pass number is set and your code still crashes, but I think we'll be fine. It's very easy. QUnit is extremely simple. I'd love to answer questions about it after the talk if you have any further questions about it, but I really think you'll be able to get started doing client-side testing very quickly with QUnit. There's a couple other tools that I want to talk about that kind of go alongside your testing. The first of those is called Sinon. And as we've mentioned before, when you're doing unit testing, in every test there should really only be one unit under test. And we've talked about how that's one small function, one small class, one small unit, however you define your unit. And those tests need to be as isolated as you can. If you're still finding yourself needing to test something that has a dependency, though, like jQuery Ajax or some third-party library, or even just some other system in your code that you just can't get rid of in this one function, mocking is a way that you can help remove those dependencies by sort of faking out some code. With Sinon, the APIs for doing mocking are, you get a spy, a stub, and a mock. And there's a lot of other things that Sinon offers, but these three are definitely the things that I find myself using the most. So those are the main ones that I wanted to bring up. So we'll start off with a spy. So a spy is a function that kind of, it can wrap something that already exists, or if you just call it here, like you see Sinon.spy, you'll get back this function that you can pass into other things. So here in this example, I'm passing the spy into the click handler for my div. And when I trigger the handler, the click event is going to run, and I'm going to be able to check on my spy that it was called once. And there's APIs for called twice, called thrice. I think it just goes to 3. You can get call counts, you can get arguments, exceptions, return values, all off of those spies. So they're a really great way to just ensure that the function you're passing in somewhere as a callback is working as you expect it to work. And it is. The second thing that you have with Sinon is a stub. And a stub has a very similar API to the spy, where you can do the called once, the called twice, the call thrice, etc., and the call count. But the difference is you can actually program in some extra behavior. In this example here, this is where I was saying you can actually stub over something that exists. And you can do this with a spy, but on the stub you get this option to do a returns. So if I'm not testing the done here in this example, but if I needed something that was making sure that my function was returning a promise, I can return like a fake promise here. And that ends up being extremely useful. So then when I call my little Ajax function that I made, which is just abstracting jQuery's Ajax, I can go in and say jQuery.ajax.called_once, because Sinon proxies over the Ajax method and gives me all these little functions just to make sure that everything was being called as I expected. But don't forget when you're done with it to restore it. If you don't do that, it will still be the proxied jQuery Ajax the next time you run your test. And something I didn't mention earlier that I probably need to mention also is tests need to be atomic, right? You don't want to do something in one test that shows up again in another test. Every test is a new thing. It's a new beginning in every test. You don't want to, in test A, create something and then test B reference something that test A did. That's just not a good practice to do. You want everything to be atomic. Just as a note there, I mentioned that earlier. So another thing you can do with the stub is fake promise. Yeah. You can change the execution path of a function. So you'll find maybe if you have some function that kind of changes depending on the arguments or depending on what order it was called in, the stub allows you to change that up. So here I can say on call 0, the first call that this callback is ran, I need it to return the number 1. The second time I want it to return the number 2, and the third time, or every time after the third time, I just want it to return 3. So you can see that when I run this, that's what happens. You get a little bit more control over how everything runs. So the third API that you get with Sign-On is called a mock, and this is you get mocking, right? This whole thing is mocking, but there is a mock object as well. So with a mock, what you can do is you can mock over any object, any function in your JavaScript code, and here I'm just mocking over this listener's object literal that has a click property on it. And the way that it works is it's sort of a combo of a spy and a stub, but you pre-program some things into the mock and then verify them at the end. So here I say mock.expects click just once, okay, and then I'm going to pass in the original listeners.click from this object up here, and then I'm going to trigger the click very similar to how I did before. But instead of passing in the spy, I'm just going to say mock.verify. And this is, again, an arbitrary example, but mocking ends up allowing you to do a little bit more complicated forms of testing. I think really spy, stub, mock is the order of complexity for doing this mocking stuff. I usually use the stub. That's where I usually stop at. But they are all three there, and they each have great features. Another tool that I highly recommend looking into is a test coverage tool. A test coverage tool is something you can analyze, and it'll tell you, it'll analyze your code and tell you exactly which parts of your code have been covered with unit tests. It's not something that you need to be dogmatic about. A lot of people have to have 100% test coverage. We have to have 100%. It's so important that all of our tests is covered. I mean, be real. You're not going to probably test 100% of your code in a large application. Maybe in something small, that's possible. Over time, though, it's just there's certain functions that you won't end up having test coverage in. Certain, you won't get it. But it is important, I think, to just have a metric, maybe 70%, 80%, something that just allows you to think about it. And the thing with using a tool like Blanket, JS Cover, or Istanbul, which are the client-side testing coverage tools, after you've ran them, you get this nice report back that shows you exactly what lines in your code have not been covered by unit tests, which is really great because you get this nice analysis of where you need to go back and do code. It's kind of crazy the way it works. It'll copy your code for you, and it puts all this instrumentation in it, and that way when you run it, it says this was called this many times, this wasn't, etc. So again, I mean, it may not be the most accurate representation of your code. We are all infallible humans, and unit testing is not going to eliminate bugs from your code. I'm sorry to break that news to you, but it's going to reduce bugs, and it's going to help a lot. So the next tool that I really like is called Plato, and it's a static analysis tool that you can run, and it kind of gives you this guide of how complex your code is. It's not the end-all be-all, but it does run some really interesting computer sciencey things, lines of code, numbers of parameters, and then you get into things like cyclomatic complexity density, Halstead complexity, lots of things. And it kind of gives you a report back on how complex you think, how complex it thinks your code is. And a lot of times it's right, because it helps you remove things like too many lines, too many nested things. It helps you, it checks for making sure that you don't have too many arguments to functions. It'll even analyze your dependencies if you're using CommonJS or require.js. And one of the best features about it is that each time you run it, it'll save a JSON file of that moment in time that you ran it. So if you go back and change some things, your maintainability can go up or down. It keeps track of your JS hint errors over time. So JS hint is a great tool we try to use as front-end developers to tell you kind of in general if you think you're going to have errors, since we compile things on the fly. So that's a really nice feature too, to kind of see how your errors have changed when you introduce new code. And the nice thing about Plato is it gives you a breakdown file by file of how complex and maintainable each file is. So automation is another important piece with unit testing. Just to be real, your team is not going to want to run tests manually. It's just, and you aren't. It's difficult to remember, and you'll just forget it, and it'll just get put onto the back burner. But if you use something like Grunt or Gulp is the newer task runner. It allows you to run and watch your code, and when it's running, you can do things like tests, concatenation, and uglifying, because it's based on automating many things. It's got a lot of community support. So if you haven't used it, it uses a config file to set it up, and it's all based on Node. I recommend using a package.json file. And kind of how you get started with it, real simply, is you install globally the Grunt CLI, and that's how you can just run Grunt, Grunt on the Node command line, or your terminal in OS X or Linux. You want to create your project directory and get started with an npm init, and this is where you'll get your package.json generated. And the reason that I like to use the package.json is because when you do npm install of your Grunt, you could do this -- save dev, and it'll add a record to your dev dependencies in your package.json, and allow you to know what version of Grunt you were using for that project. I think it was back in like 4.0 or 0.4.0 that they introduced the idea that Grunt is per project, which allows you to have multiple versions of Grunt for different projects. Kind of a different than it used to be. It used to not be like that. It was just Grunt for all the things. So that's kind of a nice feature they introduced in 0.4. And then there's lots and lots of these Grunt plugins. Typically on npm, if it's a Grunt plugin, it'll start with Grunt and it'll be dash and then some thing. The ones with the contrib mean that they were created by the Grunt team. So they're the ones that are like official Grunt plugins. So if it doesn't have contrib, it doesn't mean it's not good. It's just not an official Grunt plugin. But I mean, there's probably hundreds of them that you can use for all kinds of things. I mean, if you need to do something with JavaScript task runner, if you need to do something, I almost guarantee you there's a Grunt task for it. And it's very easy to create custom Grunt tasks as well. If you're doing, we actually, in one of our projects, we were using Knockout, and we wanted to compile our templates. And I'm sure there was probably a plugin for it, but we wrote like 10 lines of JavaScript code that looked at all the templates in the directory and grabbed all the HTML and set it up with like ko.templates equals and then the template name. So that way you could just have this one file with all the templates built into it. And I mean, it probably took 10 minutes to do, and it was a really nice thing to have thanks to Grunt. Okay, so kind of in review, QUnit is easy. There's lots of different things that you can do alongside QUnit to help analyze your code. And I have this demo here. I have a few minutes left. I don't know that I'll do the full. I wrote this demo and I did TDD it. It won't look like that, but I did do it. But I want to kind of go over the tests that I wrote. The test code here is all going to be on my GitHub at jQuery cover your client side, and I'll paste all these links later. So the example that I did was, this is kind of based off something that I actually had to do while working at Pintu, and that was that our client had a kind of a user story that said, I want to have, as a user, I want to have my zip code type in and have it auto-populate address information so that my information is valid and automatically inserted into the form. And some of the specifications and acceptance criteria was this: it needed to be reusable, it needed to validate my input, needed to show the state info if physicality was found, make sure that the info was set, and be clearable. Okay, so I'm going to pull up Sublime, get here. So I'm just going to kind of step through some of the tests that I wrote for this demo that kind of show how everything works. And I'm also going to pull up this here, and I'll do grunt watch. Okay, so what I'm actually going to do is I have a done file, and I do have a test file that's empty as well with all of my specifications in it. So it's not that test file. That's, I don't know what the heck that was. This one. Okay. So I'm going to just go ahead and put some of this over into my test file here. I already have the module in there. Okay. All right. So my zip file, this is where I'm going to write the code, and you can see it failed at first, and this is TDD. I don't actually have an address view model available, which is what I'm testing here. This may seem a little arbitrary and silly at first, but I really like to just test that the constructor that I'm going to use exists right when I get started. And I do that because it helps you make sure that your TDD stuff is going to work like you expect, right? And so what I'm going to do is I'm going to come in here to my zip, and I'm just going to say address view model. I'm going to save it, and since I'm running grunt watch, it'll run, and now my test passed. So that was TDD. Very simple. So I'll come back in here, and I'm just going to go ahead and move this over here. All right. I want to make sure that it validates my zip codes. Okay, so here's my test. I'm saying I'm going to create an instance of my view model, and I'm going to see if 3717A is valid, which I know it's not. So I'm going to say this is invalid, and then I'm going to make it valid and test it again and see if it's good now. And you can see, again, it's failing. There is no isValid function defined in my zip code plugin yet. So I'm going to come over here and grab my isValid function. And basically, I'm doing what I did earlier and just checking to make sure it's a valid number.
And now my test could you just passing. Bump up your font size just a little bit?
Yeah, absolutely. Sorry about that. Okay. So that's TDDing for you. And so I'm just going to step through a couple more of these tests. This is the same kind of type of thing where I said I wanted to make sure that it was a long enough zip code. So obviously this is not long enough. This is. Here's a good example of how I was able to stub over my AJAX request and call fetch. And my fetch code is literally going to throw an error if it doesn't work, but then it's just returning jQuery.ajax. So in this test, I'm able to make sure that when I call fetch with a valid zip code in there, that it's going to do what I expect. And if I don't pass in a valid zip code, it's going to throw an exception. Then, in terms of using a stub to return something, I'm using the GeoNames API, and they have kind of a data structure that looks something like this. It's got a postal codes array, and these weird, I don't know where admin code 1 and admin 2, they're really weird, but that's how the API works. Knowing that, that's how the API works, I can stub out my AJAX request and fake that GeoNames is working. And so now, and notice this is an async test too, because I'm actually sort of doing AJAX-y stuff. So I can make sure that I have an isLocated flag in here that basically just checks if all of my variables are set. And what I'm doing actually in this one is I'm relying on Knockout.js here, because I'm actually just changing the zip code, and I have a subscription on my zip that calls zip changed, and anytime that it changes, I'm going to fetch it and then call fetched, and then my fetched is going to set all these variables up. So that's why this test works the way it does. And then I just have a clear function. I have all these things set, and then call clear, and then it empties them out. So I actually did, I know it doesn't look like this, but when I wrote this demo, I did TDD all that, and so you can kind of see how the back and forth goes. I wrote a test, I watched it fail, I made it pass, and then went back and did some kind of cleanup on it. And so this is what my zip code checker does. So if I type 37211, which is the address for Nashville, it pulls in Nashville, Tennessee, Davidson County, and I can reset it. So that is an example of how you TDD something. Okay, I'll close. I'll get back over to here. So that is all I have for you guys today. Thank you for listening to me rant about unit testing. Again, I think it's a great practice for you guys to get into, especially on the client side. So if you guys have any questions, please feel free. Again, it's jcreamer898 on Twitter. And I'd love to just chat and answer any questions about it and talk about modern web things and whatnot. So thank you guys so much.
Jonathan, Edward's got a question there in chat. What do you recommend for unit testing views as opposed to the models, comparing template outputs, stuff like that?
So again, if you're doing testing on views, like you can do it, it's going to be a little bit more difficult. If you're using QUnit, you can stick those views into the DOM, into that QUnit div or that QUnit fixture div, and make sure that it renders like you expect. But I don't do a lot of view testing, and that's because, like I said, when you end up using something like Knockout or Angular, Backbone not necessarily so much, but you end up really being so decoupled away from your DOM and from your views that you don't even really think about it. But if you do need to go in and do some sort of view testing, then you would jump into doing like I can't remember what it's called right now. Can't remember what it's called, but you can basically test that everything works on the view. Man, what is that thing called? It's killing me. I can't remember it. There's a couple different frameworks for doing that. Selenium. There you go. Thank you. Selenium. And I know that's kind of the answer that you don't necessarily want to hear, because Selenium can be a really big pain. But yeah,